Bohr atom model. Why Bohr's model? Here you have a hydrogen line spectrum. Students, have you ever wondered why does hydrogen emit sharp colored lines in its spectrum and not a rainbow-like continuous spectrum? Rutherford model could not answer this mystery. That's where Niels Bohr comes in. Rutherford explained the nucleus, but his model couldn't explain stability of atom and line spectra. Rutherford explained the nucleus, but his model couldn't explain 1. Stability of atom and 2. The line spectra. Postulates of Bohr's atom model. 1. Circular orbits. 2. Stationary orbits. 3. Quantization of energy. The second one, stationary orbits, is the quantization of angular momentum too. Let us learn the first, circular orbits. Electron revolves around the nucleus in circular path under Coulomb force, electrostatic attraction. Electron revolves around nucleus in circular paths under Coulomb force. This is the nucleus and the electron revolves around the nucleus in circular path. This we call the first orbit. Coulomb force equals centripetal force for circular motion. The Coulomb force equals centripetal force for circular motion. The second, stationary orbits. Electrons revolves only in discrete orbits, that means stationary orbits. Electrons revolve only in discrete orbits, that's stationary orbits. Nucleus, first orbit, and we call this is n equals 1. Now, second orbit, we call n equals 2. N is the principal quantum number. This is the third orbit where the principal quantum number is 3. In these orbits, remember, no radiations emitted. In these orbits, no radiation emitted. Only specific orbits are stable. Only specific orbits are stable. Here we have the third orbit n equals 3 and the radius is r3. Orbit circumference must be an integer multiple of de Broglie wavelength. Orbit circumference must be an integer multiple of de Broglie wavelength. This is the first wave, this is the second wave, this is the third wave. So third orbits accommodate a wave with 3 lambda, and lambda is the de Broglie wavelength. And first wave has the wavelength lambda, second wave has the same wavelength lambda, and third wave has the same wavelength lambda. So third orbit circumference equals 3 times lambda. So the circumference of third orbit is 2 pi r3 equals 3 times lambda. In general, 2 pi Rn equals n times lambda. De Broglie wavelength is lambda equals h upon mv. Let us replace this value in the previous equation. So we get 2 pi Rn equals n times h upon mvn. Let's go for little rearrangement. So we get mvn that comes to the left hand side, multiply with rn, and 2 pi goes to the right hand side and divide h. So mvn rn equals n time h upon 2 pi. The left hand side, mvn rn is the angular momentum L, which is equals n times h bar. H bar is h upon 2 pi. Angular momentum is quantized. Remember, in stationary orbits, angular momentum quantized. And the third one, quantization of energy. Energy of electron is discrete, not continuous. Energy of electron is discrete. Here you have the nucleus. The electron revolves in first orbit, and the energy in this orbit is E1. When electron revolves in second orbit, it has a higher energy, a fixed value equals E2. The same way, the electron revolves in the third orbit, has energy equals E3. E3 is greater than E2. E2 is greater than E1. When electron jumps between two orbits by absorbing or emitting a photon, del E equals EF minus EI equals h nu. The nu is replaced by C upon lambda. The electron jumps from a higher orbit to a lower orbit. Maybe we think it jumps from E3 to E1. When it jumps, it emits the difference in energy of these two levels as photon with energy h nu. When the same electron absorbs the same photon what it emits, then it jumps back to the original state. What it emits, when it absorbs, it will go back to its original state. So here, there is no loss. Everything is perfect elastic collision. Frequency depends only on difference of energy levels and not on orbital motion. The frequency what is emitted depends only on the difference of energy levels but not on the orbital motion. Bohr's model successfully explained hydrogen spectrum, failed for multi-electron atoms and finer details, later improved by quantum mechanics.